is FDA. That right there is the UK. That right there is a million years sitting in that chair. We out here, bang, bang. Used to get with V-Chain, ha, but they ain't got no standards. My mama done raised me, better to be messing with you without standards.
Welcome back to the Chill Zone, my beautiful OriginTrail family. I know you guys have been waiting for this video to drop since last Saturday, but I'm getting it out to you right now, and I hope you guys are ready to dive into what I'm about to talk about. You know, of course, it is no surprise that this is not financial advice, so don't take it as that. I'm just a guy on the internet that loves talking about technology and one technology stack in particular, and that is OriginTrail. And the reason for why I love to focus on OriginTrail will be revealed in this particular video. It is, I believe, one of the most foundational and important pillars of Web3, not just within crypto. I'm talking about in all of Web3, throughout the entire globe. OriginTrail is so fundamental to Web3 that I think it is a prime time to make yourself a pioneer. So let's dive into why I say that. And of course, in order to really get to the point of explaining what the OriginTrail semantic layer, you're going to need to understand a couple things about where we've come from as it relates to Web 1.0, Web 2.0, and where we're going in Web 3.0 and Web 4.0. Now, I will be burning through these just for the sake of time because we have a lot to cover today. So let's go. Web 1.0 really refers to the read-only internet. Now, when you think back about when the internet first came out, or back into the 1990s or early 2000s, we're talking about a lot of static web pages, you know, those old clunky websites. But really and truly, back then, you really interacted with the web in a read-only manner. You weren't really uploading data and interacting on social networks and whatnot. So it was really more about the brick and mortar stores and those who just want to set up sites for whatever business use cases. Now, Web 2.0 really refers to where we are today, where you're really interacting with the web. It's known as the read-write web. You know, you interact with the web more so today with social networks, RSS feeds, and we're really more interconnected with data. The data is much more intertwined and has a little bit more semantic meaning in Web 2.0 because we are started applying more standardizations in Web 2.0. And of course, now Web 3.0 is more interesting, as I say, in my opinion, because it's really more about machines becoming more human-like and humans becoming a little bit more machine-like. Basically bridging the gap between both, I guess, entity, and bringing more alignment between what humans are capable of and what machines are capable of, and allowing us to really leverage each other's ability for semantic processing. Really and truly, in Web3, we're upgrading computers itself, giving them the power to be able to semantically discern, which is quite powerful because then you're able to automate a lot of activities for enterprises, consumers, and it even may help with redefining what we view as a secure web today. So it's very important that whoever starts building out the foundational pillars for Web 3.0 will be winners. Now, today we talk about Web 3.0, and we talk about a lot of different projects in crypto building out Web 3.0, but a lot of the things that these crypto projects are building are actually just pre-existing centralized versions that they have come and brought it into decentralizations. You're not really leveling up or pushing towards the mark where Web 3.0, the semantic layer of Web 3.0, where you're able to bring more meaning to data. Most of these things are just like really just reinventing of the wheel, you know, and adding a little bit of a spin to it. So the projects that are truly going to dominate Web 3.0 are those who understand what Web 3.0 is trying to achieve in bringing semantics, applying semantics to data. And of course, blockchain brings data integrity and a lot of security. So it has a role, but it's definitely not the biggest part of the pie of Web 3.0. Hear me out. Security and data integrity is very important in Web 3.0. There's no way that's not important. It's a foundational pillar. It is important. But the real bread and butter of Web 3.0 is going to be the semantic layer. How smart can you get your machinery to behave? How smart can your enterprise react to events in a supply chain or anything? How quick can your government respond? How quickly can you discern the connections between certain data sets or certain actions on a network? How quickly can you reform these things to bring it something that is tangible and meaningful for your organization? Web3 is going to bring that to all of us. When we start talking about the semantic layer, it's going to start ringing a couple bells because what is this thing? You know, what does this look like? What is this data fabric that they keep talking about online? What are the pillars that support this thing? Well, in order to really understand that, we're going to need to talk about a little bit of a couple technology stacks, a little bit of frameworks, and dive into really the nitty-gritty of the OriginTrail decentralized network. I hope you guys are so excited. You're going to learn really the true power of the OriginTrail decentralized network outside of what you've been hearing all along, like the traditional data fragmentation, we're solving this, we make everything work together. No, now you're going to see for yourself exactly how this works. Now there's a shift, and this shift is really away from relational databases to knowledge graphs. Now, relational databases, for you that may not know, I can't dive too deep into all this, so I'm just going to do a brief reading. It says, a relational database is a type of database that stores and provides access to data points that are related to one another. Relational databases are based on the relational model, an intuitive, straightforward model way of representing data in tables. Basically, this is tabular data. Now, when you're working with tabular data, it's great. You know, you can upload thousands of records and lines, rows of data, and have them all separated by table or by columns, and have everything connected by a particular private key, which primary key, which can link both relational database, where you can perform these queries across the different relational databases. Now, for you that may not have a harder time of understanding what a relational database is, think of like an Excel spreadsheet with all the different rows and columns. But the thing about relational databases are computers don't really understand what they're doing. When you're querying a relational database, you're creating a query that is very rigid. It says, get me this amount of information based on these criterions. You know, it's going to spit out exactly what you put in. Is very dumb. Now, it may not understand that something else is connected to another row in that table, or even understand the context of what exactly one row is. To understand this a little bit deeper, we're going to take a look at the OriginTrail documentation. It says, in Web 2, discoverability is enabled by search engines, which return a list of web links based on the query you search for. Sharing and managing data is governed by centralized services and protocols which do not share common data structures and interfaces, making it complicated to access and use this data. As an example, let's consider a traditional SQL database dataset like the one below. And what we're looking at right here is, generally speaking, what a relational database would look like. We have our columns, right? And we have one row. This is just one row of basically that Excel spreadsheet. So we have one row here. And this unique ID would be a primary key, because there's only ever going to be one ID that uniquely identifies this particular company. No other company in this table should have this ID number, so we know that this is going to be unique no matter where we are in our system. In the sense of a relational database, this one record here is a thing. It's one singular entity, and this singular entity has the name of a CME company. This singular entity has the address of this particular address, and it has this global location number of this, and so on and so forth. Now, the documentation continues to say, as humans, we quickly understand that this data is related to the same thing, a CME company. However, it is not so obvious to software, as it generally does not have enough context. So that's what Web 2 is. You're just having all of these relational databases with all over the globe, different companies, applications. Of course, you're able to interact with these sites, but you're still not really harnessing the full power of all the semantic data that's being shared on the back end, or what is already existing in data stores all over the globe, data silos all over the globe. So this is why OriginTrail is important. So we'll get into why OriginTrail, how OriginTrail is going to fit into all of this, but you should begin to understand the infrastructure that we're working with today. Now, what we're trying to move into is Web 3, the semantic, and the semantic web consists of linked data. Okay, now linked data is really the guiding property or principle of the OriginTrail decentralized network. The OriginTrail documentation says the core idea behind linked data is to actually represent all things with relationships between them in a common graph. Linked data is built on primitives called triplets, which connect a subject entity with an object entity via a relationship. Now, I know that was a lot for you to digest, but it's really not. And we're gonna go back to this very same example here. Now, in the relational database format, we have this record that existed in this form, right guys? So we can see this record here is this company, and this company has this address, and this is the number, the global location number for this particular entity. If we were to redesign this particular record and put it in the form of a semantic graph, it would look something like this. One triplet on this entity would look like this. ACME company has the address of this. Now, this is very important. This is known as an RDF Triple. This is what the OriginTrail team is talking about with triples. Let's dive into what a triple is. I'm going to be using OnToText resources because they did a great job at explaining what RDF does and RDF triples, and they have such amazing resources. So we're going to be using, and you'll be pleased to know that they are already working with the OriginTrail team, and these are one of the biggest RDF triple stores in the globe. We will talk about what a triple store is, but yeah, so let's talk about RDF Triple. The way RDF connects data pieces together is via triples. In plain English, an RDF statement states facts, relationships, and data by linking resources of different kinds. With the help of an RDF statement, just about anything can be expressed by a uniform structure, consisting of three linked data pieces: the subject, the predicate, and the object. Once again, if we go back to the OriginTrail documentation, we have the subject, the predicate, and the object, all of which are used to describe a relationship or connect some data, semantic data between an entity. So as you begin to add more and more objects to your subject, connected by more and more predicates, well, what you start seeing is more of a graph-like structure begin to appear. So this entity has the address of this address. This entity has the global location number of this number. This entity has the email address of this email. And you could continue to expand this infinitely into multiple directions. And as you start to add more and more of these connectors, well, you start seeing more of a graph-like structure begin to appear. And that's where we start talking about the concept of knowledge graphs. So knowledge graphs are really built off of the foundation of linked data. And linked data is really a set of standards and frameworks that work together like RDF and OWL and Sparkle to really to build an ecosystem where all this data lives online and can be accessed and queried via Sparkle endpoints. We will talk about that very soon. So in the same sense that relational databases are stored, on a computer server somewhere, and it's called a relational database, and it holds all these rows and records and tables and may be connected with a primary key. Databases that hold RDF triples are called RDF triple stores. Now, there are various triple stores out there, but two of the biggest triple stores that exist in today's society that are used by various enterprises are OnToText and Stardogs. Now, the reason why I want to bring up Stardogs is because they have some of the most disgusting amount of adoption I have seen anywhere. I mean, even among centralized entities, they are being used by some of the biggest entities the US Air Force, Bosch, Cisco, eBay, NASA, Bayer. I mean, there isn't really much to discuss here. These guys definitely are the de facto standard of RDF Triple stores across the globe. And they also offer some unique capabilities. So now we're going to talk about getting your data from relational database format to RDF format. Now, there are various ways of doing this. In fact, there's a process called ETL, your data that is not your non-RDF data into RDF data. Now, but the thing about this is usually very expensive and very time consuming. So there is a workaround that entities use, and this process is called data virtualization. Now, again, this is another topic that can take lots of hours and time to discuss. So I'm just going to talk briefly on it. And as you can see, it is offered as a key service by Stardogs. It's what they claim is one of their key strengths to be able to offer data virtualization on top of their knowledge graph surfaces. They help you convert your relational databases, your non-RDF data to RDF using data virtualization. So let's take a read of what they say here. They said, virtualization is known for being a flexible alternative to typical data integration, which relies upon ETL and permanent transformation of source data. However, data virtualization software is typically based on relational data structure, which does not lend itself to data that is from diverse structures, is externally sourced, suffers from frequently changing schemas, has conflicting definitions, or has uneven properties. Stardog's virtual graphs are the most mature and powerful graph-based virtualization solution on the market. Virtual graphs connect data across data silos, even without copying data into Stardog. So that's so powerful. You guys understand? They're allowing you to maintain your database as is, and they're applying a layer on top of it, which allows for all the data in your relational databases, or whatever form your data is in, wherever it is. So you don't have to move it, you don't have to convert it, you just apply their tool and it forms a blanket on top of your data, which then converts it into semantically searchable RDF triples. So it's basically like taking all of your data right now and just converting it into knowledge graph data, and then giving you so much semantic flexibility that it's undeniably powerful and the future of integration. Stardogs is not the only one. On2Text is doing some pretty great things, and they are also working with some big entities like Fujitsu and BBC. Now, data virtualization is a very important tool because it allows you to be able to connect all these different databases with a layer of metadata on top that allows you to then build these crazy semantic queries on Sparkle, which allows you to do some even crazier things and build even crazier tools. So now, On2Text says an ontology is a formal description of knowledge as a set of concepts within a particular domain and relationships that hold between them. Now, when we spoke earlier about RDF and these connections or the predicates within your RDF triples, in RDF naturally allows you to describe certain things, or at least it offers very limited descriptors on the predicates, or your connectors in your RDF graph. So this is why people started using more extensible schemas or ontologies on top of their RDF data. So you have the RDF data as your base data. They are all in triples, so they at least have some semantic layering. And then you add OWL on top of that, giving it even more semantic layering, giving it even more extensibility, giving it even more flexibility, which means you can do even more with it. So that's really how RDF OWL works together. RDF is the base layer. It's the foundation for your home. It's the concrete. It's everything that's used to build your home, build your house. And OWL is really like the paintings, the beautiful brush, the beautiful beaches I saw in Miami, all the beautiful stuff on the outside. OWL makes all of that great for you to use and see. On the topic of ontologies, it's also important to understand that each industry has its own ontology. Like if we're in the bio industry, or you're not going to be using the same sort of semantic queries in an ontology that's related to biology as using semantic queries in an industry related to the rail industry. Those two things they're two completely different domains. So the descriptors, the predicates in these RDF triple stores are going to be different, you know? So it's important to understand the domain in which you're working with as a customer in the banking industry is maybe totally different from a customer in the automotive industry. They do different things. So ontologies define the meanings between these different things and also can ensure that all different ontologies speak the same language. And so once all the different ontologies speak the same language, well, what you can do is query across all of these different things, all of these different RDF triplet stores. And if you do know, the linked open data is absolutely massive. We are talking about data from almost every sort of industry, different types of data from every industry, and it's all linked and it's all open, by the way. And in fact, let's read from On2Text. Let's read from what they posted about data virtualization, because they also have, again, they are also an RDF triple store. And let's read what they said. It says, On2Text believes you should be able to connect your data with the knowledge graph regardless of where that data lives on the internet or what format it happens to be in. Graph database data virtualization opens your graph to the wider semantic web and to relational databases. As you can see here, we have this relational database connected by the primary key, and it's connecting a person, and these are all different tables connected in this graph, all becoming one, becoming a knowledge graph. The beauty and power of knowledge graphs is the abstraction away from the fiddly implementation details of our data. The data and information is organized in a way human users understand it, regardless of the physical location of the data. I repeat, regardless of the physical location of the data, the format and other low-level technical details. It does not care how your data is or where it is. It can turn it into the knowledge graph. This is because the RDF of the knowledge graph enables a schema-less, schema-agnostic approach to facilitate the integration of multiple heterogeneous data sets. Remember, it's schema-less, it's agnostic. Remember, it's basically ontology-less. You know, it's the foundation, it's just the concrete, it's just the building, it's just a framework, it's just a structure. So it doesn't really have much bias. Now, when you start to work on implementing your ontology for your industry, that's when the bias comes in, and that's when you have to understand how you're putting together that data. But once you're in that RDF triple store, you can basically do what you want with it. This is the process of getting your data from a relational database or any sort of unstructured non-RDF data into structured RDF data, which can then be given more robustness by an ontology. And then you can use something we haven't spoken about yet to really start playing with these babies. And what is that? We're getting sparkly. I know. Yes, we are talking about Sparkle. What is Sparkle? On2Text says Sparkle is the standard query language and protocol for linked open data and RDF databases. Having been designed to query a great variety of data, it can efficiently extract information hidden in non-uniform data and stored in various formats as sources. My friends, my humble, beautiful, sexy friends, Sparkle is what allows you to search the web of linked, connected datasets. It allows you to make God queries. It allows you to be Superman on the web. I'm telling you, Sparkle. And believe it or not, it's a rather simplistic looking language. And I am actually amazed by it. I'm a little bit turned on. Now that I've been studying more, of course, this is not my background. I'm a lot less, I'm not this far along, you know what I'm saying? I'm a lot more, I'm a little bit more basic. These guys are a little bit more, yeah. So I'm very impressed and I love what's happening here. In relational databases, how do you get information out of them? Well, you use SQL. Everyone knows SQL. If you don't know what SQL is, I can't dive into this now, but you should know what SQL is. Well, how do you get the information out of an RDF Triple store? You use Sparkle. So let's get back to understanding how all of this works together. You have an RDF, so you have data that exists in some form in a relational database in CSV or something or whatever. And then you have a tool to convert that data from that non-RDF data into RDF format. That data is then stored in an RDF Triple store. While storing your data, you apply various ontologies to that data so that it makes sense to you and your users and your enterprises or whatever you're doing with your data sets. And now you can apply Sparkle to query the entire knowledge graph and form all these different connections and whatnot. I'm so excited that you guys there really isn't much more I can talk about. Yes, there is a lot more, trust me. But for the sake of just getting you guys to understand what's happening here, there's not more I really need to talk about other than to just dive into what we think now when we read the OriginTrail roadmap. So when you read this and you says, extending the DKG to the knowledge graph of knowledge graphs, fully compliant with the latest RDF, Sparkle, for seamless integration with existing knowledge graph implementation. What do you guys see here? Onto text graph DB. Stardog. Amazon Neptune. Because you must understand, these RDF Triple stores are isolated RDF Triple stores. So they do help with bridging data silos, but essentially they themselves are somewhat data silos because these entities may restrict access to their data silos. So sharing data may still be relatively difficult between these entities, even if they are in RDF format, because you know, proprietary information, you may want to sell, you may need to monetize that data or whatever constraints you have on your data. So I can see OriginTrail sitting between all of these enterprise knowledge graphs. Not one, I'm talking about all of them across the globe. Every single knowledge graph, it does not matter which one, which entity, which industry, which field. As long as you have that RDF Triple store, as long as you have that RDF data, most likely we can connect with you and allow for you to gain the enhancements of data integrity, of blockchain, the cryptographic security, the Web3, the semantic layer of Web3 with all its security can be brought to all of these triple stores via the OriginTrail semantic layer, which is open source, decentralized, and 100% governed by 100% of us. And that means enterprises and common men alike. True decentralization, true transparency, and true data integrity. I can see OriginTrail setting up to be one of the most powerful, impactful innovations of the 21st century. Hands down. OriginTrail will be ubiquitous. It will be synonymous with Web3. OriginTrail can be considered Web3. Of course, as we said, the infrastructure of data security and data integrity is unbelievably important, which is why we have blockchain. But it's not just going to be one blockchain network. OriginTrail is blockchain agnostic, which means this solution works across every blockchain. So it can connect to every blockchain. It can connect to every knowledge graph. And if we think about the properties of what data virtualization allows, you know, not just connecting relational databases. It could connect any data set, any data sources from anywhere, which means it can also connect to any blockchain. If any blockchain acts as one independent network or one independent, let's say for example, let's liken any Binance chain to one relational database. And let's say Ethereum is one relational database. And let's say the graph is one relational database. Well, the OriginTrail semantic layer will sit data virtualize all of them into one, allowing for blockchain, allowing for Sparkle queries across all of these different entities. True interoperability in an open, decentralized access. Tell me, is that not the most beautiful thing you've seen? I am very excited for the future of OriginTrail. If you are here today, you are sitting at the precipice at which humanity literally evolved. I don't know where else you can get that. So guys, tell me if you guys enjoy this kind of content coming out from the chill zone. I know it was a bit technical, but I really believe in order for us to be the best OriginTrail pioneers we can be, we must be educated on the tools we are leveraging. We must know how the inside of this thing works. And I will continue to learn. I will continue to grow. I do not know everything. Listen, I am not the most educated person in IT. I am not the smartest guy. I am not the best at this. I'm not the best at that. But one thing I do know I have is an undying passion to learn and the ability to keep learning and the ability to never give up, which will allow me to eventually surpass the natural talents of many greats like Branimir himself with time, of course, with time. But eventually, I will get there. Stay tuned.
FDA. That right there is the UK. That right there is a million years sitting in that chair. We out here, bang, bang. Used to get with V-Chain, ha, but they ain't got no standards. My mama done raised me better to be messing with you without standards.